What?
1.
Oh, right, talk, yes. Welcome. I'm going to be talking to you about automated firewall testing. And to give you the entire point of the talk right up front as a spoiler, testing is good. You should all do more testing. Any questions?
Thank you.
Excellent. Okay, we can go now. To do the typical shameless self-promotion, I'm Christoph. I'm a FreeBSD developer. In FreeBSD, I mostly try to maintain PF. PF is one of the many firewalls, well, one of the 3 firewalls in FreeBSD. PF we stole from, borrowed from OpenBSD, and we'll return it to them, any day now. Professionally, I tend to do a lot of embedded projects, quite a lot of them on that other Unix operating system nobody's ever heard of. I want to make it very clear that I'm not for sale, but I am for rent at very reasonable rates. Send me email. On to more interesting things. PF is a packet filter. I trust we all have a vague idea of what firewalls do. So they look at your packets, cluck their tongues disapprovingly, and then throw some of them away. Sometimes they let packets through. I mostly think that's usually a mistake. We imported it from OpenBSD. We did that a while ago. I actually forgot to look up when, but it's been many years since we did the last import, which means that there have been differences. The OpenBSD people keep changing their mind about what the syntax should be, and we haven't taken any of those changes in yet. We do take occasional bug fixes. There's even 1 or 2 commits with my name on it in OpenBSD, which should scare you off that particular operating system. Now that I've said, what we don't have in FreeBSD, some of the things we do have is VNet, and I'll talk more about VNet later. And what we also have is multi-core capability. So PF in FreeBSD tends to be quite a good bit faster than the one in OpenBSD. The OpenBSD people are working hard on unlocking their kernel. They are, I think, discovering, as FreeBSD did in FreeBSD 5, that this is not easy, and it's going to take a while, but they'll get there. Onto the actual topic, testing. Why do we want automated testing? Well, obviously because I'm really, really, really lazy. So if I can get the computer to do it, I don't have to do it. And that's clearly a win. Testing is a good idea because our users are very spoiled and they have this vague notion that if we give them software, it should actually work. Yeah, I know, they're very unreasonable, but what are you going to do? It's also nice that when we fix the bug, it doesn't spontaneously re-emerge. Regressions are a thing that happens. I've got some examples later on, actually on the next slide, but that's later. It's also really nice when you're doing development. I recently did some work on PF Sync, and it's really nice that you can run some tests and have an idea that I may have broken it, but at least the breakage will be subtle and it'll take a while for people to notice. It doesn't explode immediately when you try to do this. I will confess that, during development, I had quite a lot of episodes of, I think this will work, and then you run the test and it just massively explodes. But that's, that's actually when you want your tests to fail, is when you're developing, rather than, when you've delivered it to the customer and they're going to start using it. Some example regressions. There's a pattern here. I wonder if you can spot it. One of the things I did to PF was make it understand v6 fragmentation, and I hate v6 fragmentation now. Long ago, that went in and that worked and it was wonderful, and then somebody made the v6 forwarding path faster and broke PF's fragment handling. And I didn't notice for 9 months. Which is, that's kind of painful, a painfully long period for something to be broken. And that was before we had any sorts of tests for PF, so that would only happen when I, manually built a test setup and tried this out. And, my weekends are boring, but they're not that boring. So it did eventually end up being fixed, and a little while later, actually just last year around August, I think, v6 fragment handling broke again, this time as a result of a security fix. There was an issue with fragment handling not just in FreeBSD but in Linux and in a bunch of other operating systems, where somebody decided to try what would happen if I generate an evil sequence of fragmented packets. And it turns out that a lot of operating systems had list operations, and you could exploit this to make it take a really, really, really long time to do fragment lookups. So that was a denial of service vector. Someone fixed this. I really should have looked up his name. But it turns out that the fix had a bug in it, and I'll show you the code and give you a moment to try to find the bug. But the tests picked it up immediately. And it only took about 2 weeks between the bug actually being introduced and the fix going in, which, it's 2 weeks that it was broken. That's not ideal, but 2 weeks is a lot better than 9 months. It was also a really annoying bug, which, a Heisen bug. You try to debug it, you attach dtrace probes to the function, and all of a sudden the bug goes away. And you can't really tell all of your users, just run this dtrace probe and your code will work just fine. Also annoyingly, the PF tests failed over this. So everybody thought, it's a PF bug, Christoph messed it up again, nobody needs to look at this. So eventually I looked at it and discovered, very confused because I had not actually touched the v6 fragment code in PF in months. Why is this broken? Turns out it wasn't PF that was broken, it was the rest of the network stack that was broken. So here's a little bit of code. This is where fragments enter the stack. And has anyone spotted the bug yet? It is actually, I have actually made it slightly obvious. So basically what it does now is it hashes source and destination IP address, and what else does it hash? Presumably it hashes an ID, an identification somewhere. And it uses this to divide up the fragments into buckets to make it much, much easier to find them rather than run through lists. And it turns out that this hash, we allocate an array and then we hash over the entire size of the array. The array of 4-byte uint32s is 4 times as big as it should be. So we hash not only the source and destination IP address and the ID, we also hash whatever random garbage happens to be on the stack at that moment. Which makes this hash unpredictable, which means that some parts of your fragmented packet will end up in one bucket, some parts will end up in another bucket, and so you never ever manage to reassemble them. Unless, of course, you attach dtrace, and dtrace leaves predictable garbage on the stack. So they all end up in the correct bucket and everything just works. Yeah, there was some amount of swearing when I finally figured out what went on there. And it is subtle enough that it's easy to miss. So that's the patch that went in, is just make this array a bit smaller, use less stack real estate, hash only the bits that you actually mean to hash, and then everything is fine. So what do we want out of tests? Well, again, we're lazy, so we want them to be easy to write. We also want other people to be able to run them, not only so that they can run them and find their own bugs, but also so that they can write them. Because, no matter how easy it is to write a test, if somebody else does it, I don't have to do the work. We also wanted to integrate with our existing continuous integration infrastructure. FreeBSD actually has a fairly large number of tests, and we do actually run them regularly. So ci.freebsd.org if you're interested. So we run all of these tests, we build, it's always nice if your software actually compiles. And then we actually test this. Some tests failed here, It's math related, and math is something computers do. I can't help you with that one. About 7,300 tests, and these run a couple times a day, basically. You know, whenever it got done doing the last test run, it does another one. We now have someone who will actually follow up on those tests, so that's really nice. So, yeah, I maintain the firewall, so the bit of code that I would like to test is the firewall. How do you go about testing firewall code? The typical approach that you might think first time around is, okay, we get a bunch of hardware. We get, you know, like 3 machines. We have machine A, machine B, and then in the middle we stick the machine where we run the firewall, and we have machine A send the packet through the firewall machine, and machine B will go and look at, you know, did this packet make it through unmolested? That's all fine. You know, you end up with having to need a fair bit of hardware, and then when you want to test more complicated setups like PF sync, where you synchronize states of one firewall to another, well, you need 2 firewall machines, so you need 4 machines, and then you might want to test CARP to do failover, so you also need 4 or possibly even more machines. So this gets to be a bit expensive. And not only that, you know, how would you configure this machine? Well, you'd SSH into it, except that we have just configured the firewall to drop all traffic. Okay, fine. You can attach a serial port, or you can use IPMI on a different interface. But you know, your hardware budget starts to grow fairly significantly if you want to do this. Then you've got another issue that, you know, you really want to be running the latest and greatest code, so you can plausibly net boot this thing, which is really annoying if you want to test a firewall. Also, you know, you need a server to host this on, and your setup gets to become, you know, really, really complicated. You need to deal with, you know, this box panicked, so now we need to reboot it, and we can't log into it, so we need to do this over serial. But if you ever try to do interactive scripting against something that's intended to be used by a human, it's hideously unreliable, so you need a remote power switch. It's to be, you know, very complicated, very expensive, slow, because machines take forever to boot. And, you know, where would this hardware live? The FreeBSD project has some friends who would, you know, lend them the hardware and who would host it for them, but then you only have the one setup. So how do other people write tests? So this is a very unsatisfactory sort of solution. Now, it turns out that these days you can have virtual machines. Has anyone ever heard of this concept? FreeBSD even has its own hypervisor, Beehive, and this is the approach that was actually taken in a Google Summer of Code project. And it has a bunch of advantages because you don't need to buy all of this hardware, and a lot more people can build this setup. But you've still got, you know, what if we block all the traffic? Okay, we need to use the serial interface. Your configuration gets to be a bit complicated. Another issue is that the way the tests are currently run is they run in a virtual machine, because that's a really convenient way to run your tests. But if we want our tests to start up a virtual machine, we have to have nested virtual machines, and that becomes a lot more interesting. It's also, and that's probably more an artifact of how we do our builds and our tests, but it's really, really annoying to build a virtual machine from your test setup, where you might not have the source code installed, you might not have already compiled it, and building that virtual machine, actually building it can be slow, never mind booting it. So this is better, but it is still an annoying setup. So what we finally wound up with is VNet, and before we actually go into that, it might be useful to explain what VNet is. So how many of you know what VNet does? Oh, excellent. Then you guys can explain it and I don't have to. Basically, VNet is virtual IP stacks. Linux has jails, like containers, but we've had them for a lot longer. And you can associate an IP stack with this jail now, which means that you can, from inside the jail, you can set an IP address, you can run a DHCP client, and you can configure a firewall. This has been enabled by default in 12. The latest release. Everybody should be running 12. It's awesome. PF supports this now. by which I mean I don't know of any way to make it panic. I'm sure there are some, and if you know of any, file bugs and tell me about it. But it actually does mostly work now, which means you can start up a jail and give it its own firewall, which means we can just start the jail, throw some traffic at it, see what happens. So how do we do this? I don't know how many of you have played with Linux containers, but there's a lot of stuff that goes on to actually make that container behave the way you want it to behave. There's any number of moving parts and any number of things that have to be configured, and your abstraction layers like Docker will do that for you, but there's still a lot of moving parts. On FreeBSD, I bet it's actually not that difficult. That's it. That's a jail with its own IP stack. You start the jail, you give it a name. I've named it Alcatraz because I think that sort of thing is funny. And then you tell it that you want it to have its own IP stack, so VNet, and you want the jail to stay, to remain running even if no processes are running in it, so persist. That's it. Of course, I've lied to you slightly because that's not quite everything that there is to it, because while this jail now has its own IP stack, it doesn't have any network interfaces. It has loopback, but yeah. Firewalling loopback is perhaps not the most productive thing you could be doing with yourself. I'm not going to tell you how to spend your Saturday, but consider picking up a different hobby. So what you need to do is we need to create, what we do in the tests is we create an e-pair, and an e-pair is basically two network cards with a cable between them. Virtual network cards. You can't actually use them to link up two different machines, but within one machine you can link up virtual machines or jails or stuff with them. So we create one, we assign an IP address to it, and then we tell the jail that you can have this network interface. And an additional really fun thing about the jails is they make it really easy to execute things inside the jail. So there we go, execute in the jail ifconfig epair 0b, set this IP address, and up the jail. And after we've done that, we have one external interface on the host system. We have one internal inside the jail. And I should actually include the name of the jail here, so there's a typo in the slides. And then you can ping the jail. There you go. We're testing that the network stack works. ICMP echoes are not very exciting, but they do actually exercise a fair bit of your functionality. So why don't we take a look at a basic test? That's not the entire test. That's basically just the header. We use ATF that we have, we noticed that NetBSD had left their front door unlocked one night, so we went in and took their testing framework. Quite entirely possible. I haven't actually looked at the new one yet because they keep locking their door now. So what do? We declare a test case for v4. It's got a cleanup function. We'll see the cleanup function after we've done the really interesting things. You can set a description, and this test actually wants to run as root. The nanny state of FreeBSD has decided that if you want to create network interfaces and start jails and configure the firewall, maybe we shouldn't let every single user on the system do this. Yeah, I know, but that's how it is. So that's just setup code. You can forget this. It's not important. This is the actual test, and it's a very basic test, but it is already a useful test. It tests that the firewall works and blocks packets. So what do we do? Some initialization code. Everything the initialization code does is make sure that you've actually loaded the BF module. It is very hard to test a firewall if the code's not in the kernel. So if it's not loaded, this test will just be skipped. Next step, create an e-pair. Set up an IP address on the e-pair. So basically what we saw before is we want an interface in the host, we want an interface in the jail so that we can send traffic back and forth. Make a jail. There's a wrapper around this just to make it slightly easier to type. What it also does is it keeps track of the list of jails you've created so that in the cleanup it will automatically destroy all of these jails. Quite nice to actually clean up after yourself. Set an IP address in the jail, and then a sanity test check. Can we actually ping this jail now? So if things fail here, it's not actually a PF bug, because PF is not enabled yet. But we might as well test that this works. So ATF check, run this command and check that the exit status is 0. Ignore the output and then run a ping command, one ping only, with a timeout of 1 second, because if your echo request hasn't made it to a jail running on the same host within a second, something's probably wrong. Next step is we enable PF, and PF defaults to allowing all of the traffic to go through. And then we can still ping. And then when we tell PF to block all of the traffic, we can't ping anymore. Hence the exit status 2. It won't work anymore. And that's a very basic test, of course. The firewall should be able to make more fine-grained decisions on your packet, let's say, than allow all packets or deny all packets. But it's basic functionality test. The rest of this test actually does a little bit more, but this is all I could fit on the slide. But you can see how you can fairly trivially test that I can filter out only ICMP echoes, and then I can still telnet into it or whatever. Cleanup code, cleanup, and then add the test case to the list of test cases. So if you run this using QA, which is another tool that we happen to spot lying in an unlocked garage from NetBSD, you can tell QA, run this one particular test, and it will run the test, and you will see that the test took 1.2 seconds. 1.2 seconds, of which it spent an entire second waiting for an ICMP reply that we knew would never turn up. So 0.2 seconds to start up a machine, a jail, configure the networking on it, configure the firewall, and tear it all down again. I think we've satisfied that, these tests are quick. We've also satisfied that everyone can run this, because you don't need anything. If you've got a FreeBSD system running, FreeBSD 12 system or current, or even an 11 system, although there are a number of bugs still in vimage in 11, so it's not enabled by default there. You could build your own, but if you want vimage, you really want to be running 12. It also stores the test results, so you can later on go and have a look at what was the output, what environment variables were set, what was the timing, all sorts of things like that. So this was a very simple test. I've mentioned pfsync before, so let's take a look at a really complicated test. This is just half of the test, but this is a very basic test for pfsync. It synchronizes states from one firewall to another. So what do we need? Well, we need an interface over which they can sync. We need 2 jails that will have states, and we will just send our traffic from the host. So we create jail 1 and jail 2. Yeah, naming the jails after real-life jails joke got a bit old, so they're 1 and 2 here. So what do? We set up IP addresses for the external interface, for the sync interface. We configure pfsync, so we tell it what device it should synchronize over. All this does is, if you don't configure IP addresses in pfsync, it will just multicast. So if you have two machines connected over a straight-up link cable, it will just magically work. You don't need to worry about it. Set that up, do the same thing on the other interface. So that's all just set up. What do we do next? Well, we turn on PF. We set some rules on both hosts. We set up the interfaces, and then we send a ping to it. Select the correct source interface, just in case that would go wrong. Give pfsync some time to actually synchronize the states, because this is not an instant process. And then we go and look not at the jail that saw the traffic, but at the other one. Do you have the corresponding state for this? So we just grab and go look, does this state exist? If it does not exist, we error out. If it does exist, everything worked, and it's awesome. You had a question?
Good question. Did you ever try to use things like to split down to see if it's really a arriving and adjust state?
So the question is, have I tried to use TCP dump to see if it's arriving? If the traffic arrives, I have not. Mostly what I've tried to do is make it really easy on myself to actually test this. So rather than look at, do I actually get this packet, we check, do we get the effects of this packet having been delivered? So typically things like ICMP echoes, I don't check that the reply arrives, I check, is ping happy that the reply arrived? So theoretically that does mean that you could have bugs like the firewall corrupts the payload of an ICMP echo reply packet and ping doesn't check for this corruption or expects this corruption. That is a bug that you wouldn't notice in this setup. So that is arguably a weakness of this setup, is that you're not actually doing formal testing that is the TCP or IP output actually standards compliant. All we're testing is FreeBSD itself happy with the packets it sees. I think that's a price worth paying because doing the full formal verification is much, much harder. And it turns out that, if FreeBSD does TCP wrong, we're going to notice. If nothing else, the Netflix people will shout at us. Well, they won't shout, they're actually nice people, but they will tell us. Now that I've got you all fired up for these tests, where can you find them? The source code for these tests lives in user source, assuming you've installed your source to user source, test sys netpfil pf, which mirrors the structure of where the code for pf lives. They get installed to users test sys netpfil pf, which again mirrors the structure of where they're installed. So you can, if you want to run them yourself, you might want to install some tools, QA to actually run the tests, and I never know how to pronounce this. Scapy? It's a Python tool that lets you generate and analyze packets. So there are some tests where I actually deliberately create very specifically formatted packets and actually go look at them. Some of the fragmentation tests do this, where you can deliberately create corrupted packets, for instance, which might also be a really interesting test to do. If I knew of any malformed packets that cause panics, for instance, that is something I would definitely do, is create this packet to attempt to provoke this panic. You want to load, well, pfsync, because the pfsync module depends on pf, so it will implicitly load that one. And then you can go to that directory and as root run QA test, and it will run through all of the tests for pf. Takes, I forget, about 30 seconds. We don't have that many of them yet, but it turns out that having a couple of tests already gives you a lot of value. So you don't need to think that, it's a firewall with hundreds of features, so I need to write thousands of tests. Ideally, you want to have thousands of tests, but it turns out that just having, 5 of them already tests a lot of the functionality of PF, and you can get a lot of, fallout accidental tests along the way. For instance, this IPv6 fragmentation bug, well, the reassembly bug, we didn't have code to specifically test reassembly. PF just tested this accidentally while it was testing something related, but not quite that code. So you get a lot of value out of relatively little investment for tests. At this point, I would appeal to authority and get some sort of really profound quote from someone to reinforce my point. I didn't find one because I was lazy and I didn't look for one. So the quote that you're getting is, the tests are good and you should write more tests, and it's from me just now. So, it is a very well-sourced quote. I hope, to continue to try to persuade you that tests are a good idea and that you should try to write more of them. What is in it for you? Well, you can prototype your own setups. If you want to play with carp or pfsync or pf and you don't happen to have a box lying around to run this on, just spool up a jail and test this. And if you write them as a test, you can keep running this and you can be sure that this won't actually break. So if you have a very specific use case that relies on a feature that you're not sure other people are using, send me a test case, we'll include it, and you can be sure that the next time somebody breaks it, it will get fixed, rather than you noticing, when you try to upgrade to a release 2 years after somebody broke the feature for you. Another case, and this is what I really want to focus on, is when you report a bug to PF, I have to try to reproduce it. I have to try to work out what your test setup is, and quite often, in most cases in fact, I spend more time trying to work out what your setup is, how it breaks, than actually debugging the problem. So if you give me a test case, you've already done more than half of the work. Not only that, if you give me the test case, when I fix the bug, I would like to have a test for it. Well, you've given me a test case. Most of the work is already done. So if you have a pet bug that's been really been annoying you and you want it fixed, that's the best way. Actually, that's not true. That's the second best way. The best way is to pay me. No, that's not a joke. I'm very money motivated. If you pay me to do work for you, I will do work for you. But if you don't want to pay me, you should, but if you don't want to pay me, write the test. And I promise you, well, I'm not going to promise you that I will absolutely fix your bug for you, but it does vastly increase the chances of it getting fixed. I've had someone report a bug to me in the NAT system, and it was a very strange bug, and I had no idea of where it was or how to fix it, right up to the point where he gave me a trivial test case for it. Not quite in this format yet, but he gave me a configuration file and a little shell script, and you do this, and I see these problems. And then I could suddenly reproduce the problem, and it only took a day or two to fix. For a problem that started out as a description of, I have this very large NAT setup, very large. I run a university, so a lot of students, a lot of traffic flowing through this, and every once in a while, without any obvious cause, the machine will just stop forwarding packets. And then it will sit in that state for a few minutes, and then it will start forwarding packets again. Until we had the active description of this is how you trigger it, and then it only took a day to, well, it took barely any time at all to figure out where the problem was and fix it. So write tests, illustrate your problem, make it easy for other people to fix the bug for you. Or, you can also fix the bug yourself, and that's awesome, but it turns out that reviewing code means that I need to understand what the problem is, which means that I need to know what your setup is and what the bug is, which is also accomplished by a test case. If you want to make it even more likely that your bug gets fixed, write the test case, write the patch, and submit that. But, whatever you do, test case, test case, test case. If you don't want to be the first one to do this, you won't be. Olivier Cochard-Labé is one of the contributors to the FreeBSD project, and he's really good at benchmarking things. And for his previous employer, he really cared about IPsec, and it kept breaking, and he was really sick of this. So he wrote tests for it. And now there are tests, and IPsec isn't broken. And if somebody does break it, Lee Wen will shout at them. Well, that's a lie. Lee Wen's a really nice guy. He won't shout, but he will tell people that it's broken and that they should fix it. And this also means that, because we run these tests a couple of times a day, if you commit something that breaks IPsec today, we're going to notice tomorrow or on Monday, and you're going to have a bug assigned to you on Monday or on Tuesday. So it will be very fresh in your memory. Before I belabor the point anymore, does anyone have any questions? Have I been that clear? Yes, go ahead.
Well, thinking of PF as filter, why don't test PF as a filter on the low level? I mean, when you, for example, use ping, there's a lot of things that can go wrong. when the ping doesn't exits with the exit code of 2. And you're not quite sure if the, as you mentioned before, that PF is broken.
Yes. So the question is, when we test PF based on the ping tool, there is a lot of code that needs to run. So why don't we simplify this down so that we're only testing PF? That is a valid approach to take in testing. I think the advantage of not doing it that way, of doing we just use the ping tool to send the packet, is twofold. The first is that it's much easier. We don't have to write any code to send ping messages. We don't have to write any code to receive them, to validate them. That code is already there. So we can just use it. Makes it much easier to write the test. Another side effect of this, and you can argue if that's good or bad, is that you test much more code. So that's the incidental testing I was talking about, like we had with the V6 reassembly code. You are incidental to this test, you are also testing ping. And that's an upside because you test more of the code and the functionality of the system. It's also a downside because when it breaks, it's not immediately obvious where the breakage is. So if somebody breaks the ping tool, changes the return code, changes it so that it no longer sends ICMP echo requests, or it thinks that they're corrupted when they're not corrupted, this test is going to fail and is going to look like PF broke. That's arguably a downside, but hey, at least we know that something's broken. And especially if you run them these tests fairly frequently, you will typically not be looking at thousands upon thousands of commits that could have caused the problem. So if you look and you see, today it was working, tomorrow it was broken, in this time span we had 50 commits, 40 of them touched unrelated driver code, 5 of them touched the IP stack in some way, 1 of them touched the ping tool. There's not too many things that could have caused the breakage. It's a valid point, but you can argue it both ways. Yes?
As far as I know, there are other firewall implementations of FreeBSD, such as IPFW, I think?
Yes.
You have test cases for these subsystems as well?
So the question is, do we have test cases for the other firewalls in FreeBSD? So FreeBSD ships out of the box with 3 firewalls, IPF, IPFW, and PF. I'm not going to go into the reasons for this because honestly I don't know if I understand and agree with all of them, but the fact is we have 3 firewalls. We currently don't have tests for the other firewalls. Right now PF is the only one that has these tests. It would be trivial to look at the PF tests and go, okay, now I'm going to rewrite them, or I'm going to write similar tests for IPFW or IPF. I believe both of them also support VNet. It does actually take some changes to the firewall to make this work, but to make VNet work, not to make the tests work. The tests do assume that you have VNet. So we don't have them right now. I actually just this morning posted an idea for a Google Summer of Code project. So if there are any students who are interested in working on firewalls and testing, there is a project, write more tests. Ideally, it should be possible to write a test so that it works on all 3 firewalls. There is some functionality like PF sync that is common, is unique to PF, so you would have to write a test specifically for PF. But for things like, drop this packet, allow this packet, keep state, you could write tests that would work on all 3. We don't have them right now. It would be awesome to have them. Any other questions? Okay, thank you very much for your attention.
I want to see the battery level.
Do your tests include any randomness?
So the question is, do the tests include any randomness? Right now they do not. Again, randomness in tests is something you can argue both ways. So it's good because fuzz testing is great because you can trip over unexpected bugs. It's bad because you can't necessarily reproduce your results. Right now there is no randomness in it, or no deliberate randomness anyway.